Edu. Good morning, students. So far in last class, we have to discuss with that FA growth algorithm, how to construct the FP tree. These are the concepts we have to complete it in last class. So once we have to revise the syllabus, in the syllabus we have to discuss what is the introduction part of the data warehousing and data mining, and the data pre-processing, classification, and classification alternative techniques, Bayes theorem and Navy Bayesian classification, Bayesian belief networks. And also you have to complete the association analysis regarding to the basic concepts and algorithms, problem definition and frequent item set generation, rule generation, compact representation of the frequent item sets, and FP growth algorithm. So these are the concepts you have to discuss. So far, we have the only one remaining unit, that is the 6th unit. So now in today's class, we have to discuss that. That is the association analysis. Once we have to revise basic concepts and algorithms.
பரவாயில்ல.
Good morning, students. So here what are the drawbacks of the prior array algorithm? And each step of the candidate sets have to be built. To build the candidate sets, the algorithm is repeatedly scan the database. So whenever you want to particular item, so from the starting onwards, you have to repeatedly you can scan. Whereas in a prior, for example, 10 times it will be repeated. First time it will be scanned. Again, again you have to getting money. First time you have to scan, and again you have to scan the second time also.
ఇది గడిది
ఒకసారి చూసి పోతాము మన పోతే అదే బాబా ఆ స్థాయి ఎవరికి లేదు
చేతికొద్దు నిలబడతా ఉన్నప్పుడు చేతితో మానేయాలి ఎవడ ఖాళీగా ఉన్నాడు ఇక్కడ
చేతి
Good morning, students. Now, in association analysis, mainly we have to discuss with that two algorithms, that is the epic growth algorithm and a priori algorithm. So, in association rule mining, the relationship between the two are more attributes. It is mainly in the form of antecedent and then consequent. For example, whenever you have to whenever you want to go supermarkets, so that time there will be 200 customers on the particular day. Out of 200 customers, 100 people are brought by the one item and 100 people are bought by the another item. So 50 people have to bought by the another item. So the association rule of the customers who can represent by this the particular item. One customers will have to buy the two items with the support of 50 by 100, that is 25%. Only 100 people have to bought, that is 50%. In the confidence, we can say that 50%. So here you have to give an example. Out of 200 customers, 100 people are buy the chicken, and out of 100 customers who bought the chicken, 50 persons have bought the onions also. The association rule would be that the customers buy the chicken and buy the onion too, with the support of support 50 by 200, that is the 25%. And confidence, 100 people they have to buy the particular item, that is the chicken. So 50 people are buy the onions also. That is the simply you can say that is the confidence, we can say that 50%. So based on this here, this is the association rule mining with the support and confidence. Association rule mining is generally it is a two-step process. In the two-step process, first one is the finding the frequent item sets, and the second one is the generation of the strong associations rules from the frequent item sets. So first one is the finding frequent item sets. The a priori algorithm I want to represent it here. Finding frequent item sets can be found using the two methods. One is the a priori algorithm and the second one is the epic growth algorithm. A priori algorithm generates the all item sets by scanning the full transactional database, whereas the epic growth algorithm only generates the frequent item sets according to the minimum support defined by the user. Since the a priori scans the whole database multiple times, it is very more resource hungry, and the time to generate the association rules, increasing the exponentially with the increase in the database size. On the other hand, you can say that epic growth algorithm does not scan the whole database multiple times and the scanning time. So what is the difference between here? The a priori algorithm, every time it will be scanned. So automatically it increases the exponentially with how to increase the database size. But whereas in epic growth algorithm, you don't want to scan the whole database multiple times. That is the difference between that a priori and epic growth algorithm. So here epic growth algorithm much faster than the a priori algorithm. Simply you can say that. So okay item ni number of times you call this on that automatically it takes more time. But whereas you have to take, once you have to consider, so no need to repeat again. That is a easy. It is faster than the other algorithm. So that is the difference between the epic growth and a priori algorithm. So here I want to see the epic growth algorithm, how you can implement. That is simply you can implement it with the FP tree only. That is the frequent pattern tree. Compressing the transaction database to mine the association rules by finding the frequent item sets into a frequent pattern tree or FP tree. So let us see the example here. Asparagus, corn, beans, tomatoes, squash. So here, that is simply you can say that A, C, B, T, S. That is the list of items. That is the 5 items are there. Those 5 items, the first transaction the first customer, they have to purchase BAT, that is the beans, asparagus, and tomatoes. So that is the way you have to, these are the items you have to purchase by the first transaction. And similar way, totally we have to consider the 9 transactions we have to consider here. Out of 9 transactions, first transaction T1 you have to represent with 3 beans, asparagus, tomatoes. Similarly, transaction T6 also contains the same asparagus, squash. Let us also consider the minimum support of the small transaction data 2. Hence, the minimum support is 2. First of all, you have to consider to create the table. Beans, totally beans out of 9 transactions, beans how many times they have to purchase? 1, 2, 3. And this is the 4, 5, and 6. So 6 people have to purchase the beans. Asparagus, you have to purchase it by these 7 times. So 1, 2, 3, 4, 5, 6, 7. This is the representation in appraisal algorithm, as well as in appraisal algorithm, you have to represent the frequent item sets. You have to find out like this. So 7 times they have to purchase. Similar as squash, you have to represent it as 6. Corn is purchased by 2 people, and tomatoes are purchased by the 2 people. So this is simply out of count each item. Squash has been brought 6 transactions. AR T3, T5, T6, T7, T8, and T9. So support count is of the squash is 6. Okay, this is the support count. Next one is the support count we have to represent it here. That is the 7, 6. Which item is, so now all these 5 items, asparagus or support count is high. That you have to represent it as top of the table. Then now you have to sorting this support count, automatically you can get the asparagus in the top position. So now you have to consider the 7, 6, 6. And corn and tomatoes are only 2 people they have to purchase. Now the by using this data, I want to create the one frequent pattern tree. So I want to create first one, that is the structure. First one, initially you have to represent it as null, and how many people they have to purchase? That is the in first transaction, 3 items they have to purchase: asparagus, beans, and tomatoes. So here you have to represent it as here you have to purchase it as purchased. That is the first one. Initially, you don't have any in FP tree. It is the null. So then null you have to consider as the root of the table, root of the tree. And now with that first transaction A1, that is the A is the A, B, C, A, B, T, you have to purchase the items. So A, whenever you have to purchase the items, that once you have to getting, that is you have to represent it as support count. Support count is 1, and B is also support count is 1, and T is also support count is 1. Once first transaction you have to complete it, now you have to perform the second transaction. In the second transaction, you have to purchase. Here you have to see the about second transaction. That is the AC. AC is the second transaction. In the second transaction, they have to purchase. Here you have to see. This is the A is repeated again here. We have to consider that its support count is incremented. That is the ones. That is the A. Its support count is 2, and C is AC. So support count is 1. So after second transaction you have to complete it, you can get like this. Then third transaction we have to consider that is the in the third transaction you have to purchase AS. So whenever you have to getting the AS, automatically again A is repeated. Again A is repeated. Now A will be incremented to 1. That is, the A supports count is 3 and S supported count is 1. Like this way, you can process here. Again, you can get the fourth transaction. In the fourth transaction, you have to get, that is the BAC. BAC you have to represent it as here. BAC you have to consider here. This is the B. B is incremented to 1 and A is incremented to 1. And C is also, we can represent it as C is, you have to represent one row that is the always in forward direction only, that is the A, B, C. So A is incremented to 1, B is incremented, and C is also you have to represent it as 1. So like this way, we have to construct the frequent pattern tree. See here like this. So after construction, construct that is the next one is the BS. So BS we have to represent it here. See here, this is the BS in transaction 5. So like this way, you have to process. Finally, you can get this diagram. Transaction of ABS is finally you can get like this. So totally A is transaction 7 times and B is transactions we have to perform it 6 times and S is transaction we have to discuss it with the 6 times. So that is the T. That is the item, that is the S A item you have 7 times, you have to repeat it. B item you have to repeat it 6 times. S item is repeated, that is the 6 times. And C item is repeated 2 times and T item you have to repeat it 2 times. This is the finally you have to construct the FP tree. So this is the compression conditional DB. It's asperges 7 times, bean 6, and squash 6 times, corns 2 times, tomatoes 2 times. So finally, what's the node links? You have to represent it already in last class. We have to shown how the node links you have to represent it. So finally, you can get this FP tree. Once the node links you have to implement it. Now, tomatoes conditional pattern base you have to represent it as AB. So AB, how many times you have to repeat it? And ABS, how many times you have to repeat it? A is conditional FP3. A is repeated 2 times. B is repeated 2 times. So frequent pattern generation, AT is 2, BT is 2, and ABT is 2 times. So similar way, corn, squash, and beans, frequent pattern generated, and finally you can get the strong association rule for the frequent item sets. With this 3 item frequent item sets, we have to represent it here. ABT is the 2 times, ABS is the 2 times. That is the 3 item you have to represent it here. Similarly, 2 item frequent sets are AT is 2. So these are the 3 item we have to represent it, 3 items the frequent item sets. That is the frequent item sets in a prairie as well as F growth. That is the difference between this one a prairie algorithm as well as frequent pattern. Thank you. So in next class we can start the 6th unit. So up to now you have to completed the 5 units. In next class we'll start the 6th unit.